All right. So, getting into chapter 5. Going to be working with parts of triangles and what they all mean and all that stuff. So, starting here with focus on mid-segments of the triangles. We're going to talk about what that is in a moment. But first, what is the midpoint formula? So, midpoint, if you think back, m is going to be equal to x1 plus x2 over 2. And then that'll give you your x value of the midpoint. And then you're going to take y1 plus y2 over 2, and that'll give you the y to the x point. So what we're talking about here are the point x1 comma y1. So your first point, the x and the y, and then the second point, x2, y2. Now, a couple other formulas. So we'd have distance formula, which we'll use this as well here in a little bit, so that's why I'm bringing it up. But it's x2 minus x1 squared plus y2 minus y1 squared. And the other one is slope that we're going to need here in a little bit. But there we go, y2 minus y1 over x2 minus x1. So what we're going to be getting into is that mid-segment of a triangle, which is going to be the segment that's going to connect the midpoints of two sides. So what we're talking about is if we're looking at, say, this triangle here, R and S are both midpoints of P and O and of P and Q here. So RS is the mid-segment of that triangle. All right? Go back here so in case you're still writing that's down. Now, that mid-segment connects the two midpoints of the two sides. It's also going to have some information regarding that third side here, which we get in our theorem 5.1. So the triangle mid-segments theorem is that if a segment joins the midpoints of the two sides of a triangle, so in other words, if it's a mid-segment, we know that segment is going to be parallel to the third side. It's also going to be half of that third side's length. So when we go back to this triangle here, so we know RS here is going to be parallel to the third side OQ. It's also going to be half of what OQ is. So if OQ is 6, RS is going to be 3. Now, we're going to do a different type of proof that we haven't done before, called a coordinate proof here, to prove that this is the case. So to do a coordinate proof is going to involve using a coordinate plane, and we're going to put our geometric shape on it. Now, we want to put it so that our corner is on the x-axis and y-axis where they cross here, called the origin, at 0, 0. We also want a side to go along the x-axis, and then we'll get into more here in just a minute. But what we're going to do is we're going to use variables in order to prove this, because to prove something, we have to prove it's true for all cases. So if we use numbers, we would only prove it for that case. So then we'd have to do another set of numbers and prove for that case. Another set of numbers proved for that case, and so on and so on and so on until we covered all the possible things. So we would be doing this forever. So we're going to use variables to represent all cases and show that it's going to work. So first thing we got to do is we're given that R is the midpoint of OP. So we know R, midpoint of O and P. And that S is going to be the midpoint of PQ. So PQ, S is the midpoint there. And we're going to prove that RS and OQ are parallel. And we also know that RS is going to be half of OQ. Well, first off, we would go through and we would put coordinates on each of these points. So obviously, if O is on the origin, it gets 0, 0. Q here, which you can't see, is going to be at A, comma 0. Well, why A, comma 0? Well, we're on the x-axis, so that's why our y is 0. But we've traveled on that x-axis a distance away from our origin. We don't know what that distance is, so we're going to put a variable a, so that's going to cover any distance that would be. Next, up here at P. Again, we've traveled a distance on x, so we have to do a variable. It's not the same as what C is, so we use a different variable B. And we're off that x-axis. We've moved up on the y, so now we need a y value. Well, again, we don't know if it's the same distance we moved B. We don't know if it's the distance we moved A. So we do another variable, and we call it C. You can use any variables there. We just picked A, B, and C for this one. So we have to find our coordinates of R and S next, because they don't have coordinates. Well, we know they're the midpoint, so we're going to do the midpoint formula. If I could right? So midpoint here, and actually I'm not going to use them. Now that I think about it, I'm going to use R. Because, hey, we're dealing with point R. So R is the midpoint of O and P. So my two x's of O and P are B and 0. So B plus 0 over 2 is going to give me that first x coordinate. So I look at my y's. My y's are C and 0. So C plus 0 over 2. Now, if I add 0 to anything, I'm still that number. So what this goes to is B over 2 comma C over 2 for R. So that's that coordinate. The other one we got to find is S. So S is between P and Q, the middle. So our x's are A and B. So if I did A plus B, or if I did B plus A, it doesn't matter because addition is commutative. We can switch our order. But we need those two x's, A and B, over 2. Our y's is C and 0. So C plus 0 over 2. So these here being different variables, we can't put them together. So it has to stay A plus B over 2, comma. Our 0, though, we can drop, so C over 2. All right. So we now have these two coordinates. So now we can start working towards our proof. So in order to prove that the two lines are going to be parallel, we have to have the same slope. So let's find slope of RS. So slope we said was we're going to take our y's, which is C over 2 and C over 2, and subtract them, over our x's, which is going to be A plus B over 2 minus our other one of B over 2. Now, we are over the same thing, so B minus B would just be our A over 2. Our top, though, if I have C over 2 minus C over 2, well, I'm going to have nothing. And on any fraction, if our top is 0, the whole thing is 0. So next, we're looking for OQ. We want it to be the same slope. So slope of OQ. So our x coordinates are 0 and A. So A minus 0 on the bottom. Our y's are 0 and 0. So 0 minus 0 on top, which turns into 0 over A, which is 0. So same slopes. So we know they're going to be parallel. So we've got that part covered. The other part of this is we have to show that RS is going to be half of what OQ is. So we're going to find the distance of RS first using our distance formula. So the square root of I think I got a hair in my mouth. Sorry about that. So distance of RS. So distance is the x's subtracted. So A plus B over 2 minus B over 2, and then they're squared. Plus the y's. Well, C over 2 minus C over 2 squared. Well, C over 2 minus C over 2 is 0. So 0 squared is still 0. And if we add 0, it's all nothing. So that doesn't matter. It's just this over here that's going to matter. Now, same thing as what we did over here. So the b's would cancel because we're both over 2. So we subtract the tops. B minus B would be 0. So we just have the A over 2. And that is squared. Now, if we only have one term that's squared underneath the square root, the square and the square root cancel. And we're left with the distance of A over 2 for RS. Next, OQ. Well, if we start with our x's, we'd have A minus 0 squared plus our y's of 0 minus 0 squared. Well, again, 0 minus 0 is 0. 0 squared is still 0. Adding 0 to anything is itself, so that's gone. A minus 0 is still A, and it would be squared. Again, if we have one term that's squared underneath the square root, that cancels, and we're left with A. So therefore, we just showed that RS is going to have a distance of A over 2. So in other words, 1/2 A. And OQ is A. So we just showed that, hey, RS is going to be half of what the OQ distance is. So we're going to finalize this by saying those three little dots that mean therefore. So we know RS is going to be parallel to OQ. Or QO. So we showed that by showing that these two both have the same slope of 0. the other part of this, so and RS is going to equal 1/2 of OQ, which we showed over here. RS was half of A, OQ is A, so that's half of it. And there's our coordinate proof. So that's how coordinate proof is going to go. We put in our coordinates. Again, we're using variables for our distances because we need to show it's going to work for any of these situations. So by using those variables, we show that, hey, we got the same slope. We have half our distance. We proved it's true. And now we can move on. So, like I said, coordinate proof was what that's called. We're using geometry and algebra to work it all out and making it work. Now, in this diagram, we know H, J, and K are midpoints. So your homework that you're going to be working on is going to be more like this. It's not going to be doing a coordinate proof per se. You may have one or two, but that's something, if you have questions on, let me know. But it's going to be this here stuff like this. So if we know that those three are the midpoints, well, we just proved that the mid segment is going to be half of the segment that's parallel to. So if we do HJ first, and then JK, and then FG. So HJ here is the midpoint of this triangle, and the side that it's parallel to is EG. We know EG is 100, so ours has to be half of that, so HJ is 50. JK is another mid-segment. It's parallel with EF. EF is 60, so half of that would be 30. FG, so now we have a side, so we need to look at, well, what's its mid-segment? Well, its mid-segment is HK. We know that's half of this other side, so if we doubled that, we'd get the full length. So FG then, if HK is 40, would be 80 for FG then. Okay. So, going to be doing like this. Think about those properties that we just proved. How can we use them? Well, if we know the mid-segment's half, the other one has to be a full. So if we cut it in half, we are a mid-segment. If we double our mid-segment, we are full. Okay. Now, you're also going to have one like this. It says A, B, and C are the midpoints. So what would the parallel segments be? Well, if we start with AB. AB is going to be parallel to DF. So we're going to go AC. Well, AC slopes this way. It's parallel to EF. And lastly, we have BC. So BC here is going to be parallel to DE. Okay. And I am totally off the screen and you didn't see any of that. That is my fault. I'm sorry. So AB, we'll look for which ones are parallel. So AB here, parallel with the bottom. So DF. AC, going to be parallel with EF, this right side. And BC here, going to be parallel with DE. And that's how we get those. So here we're just naming which ones are parallel. Well, we know if those are midpoints, then they make mid-segments, and mid-segments are always parallel with that third side. So that's why we know that. Lastly, you'd have one like this. Find the measure of VUC, that angle. So we're looking for this one right there. If we know that X here, so YXU, that angle is 65. Well, what would VUZ be? Well, if we start looking at this, we have one tick mark on either side. So that means these segments are the same. So that means V must be in the middle. So V would be its midpoint. Same thing up here. We have the double tick marks. So again, those are both congruent. They're the same length. So U has to be the midpoint. So if we know that these two are midpoints, that makes UV a mid-segment, which tells us that XY will be parallel to UV. So XY parallel to UV. So knowing these are parallel, that allows us to go back a few chapters to our pairs of angles. Well, if this is parallel, this would be your XZ, your transversal. Well, what type of angles are these two? Well, these two are corresponding angles, and we know that if the lines are parallel, corresponding angles are congruent. So therefore, the measure of angle BUZ equals 65 degrees. And that is it for this lesson. So let me know if you have any questions. again, if there's something that you're going through, especially say with that coordinate proof that doesn't make sense, rewind it, watch it again, or pause it to give you more time to write stuff down. Remember, this is the video, you can do that. Also, if you have questions, send me a pan, send me an email, send me a message on Google Classroom. I'm here to help. Please take me up on it. Lastly, I don't know where I was going with that. But anyways, yeah, that's it for this lesson. Again, let me know if you have questions. Otherwise, until next time, we'll talk to you later.